improper integral, it's kind of like the word improper fraction. If the top of the fraction is bigger than the bottom of the fraction, that doesn't really make it bad morally. It's not like we're going to send this fraction to hell or something. Improper is just a stupid term for that. I mean, there's nothing wrong with it. I would assume it's I'm just assuming, but I'm guessing that from grade school, right? Those kids, you always want them to reduce something like that to a mixed number. They write it as 1 1/3. So I assume they call it improper there, so the kids think of it as something you can't read. You got it right or something else.
These were all the proper ones so far?
Yeah, everything else has been proper.
So, but for us, we realize algebraically speaking, this is far better than 1 1/3, isn't it? I mean, if somebody asks you to do 1 1/3 x and they tell you that x is 6, even you guys, a lot of you guys would screw it up. You would, because you don't realize that really there's a hidden symbol between the 1 and the 1/3. It's a plus. Right? If somebody asks us to do 4/3 x here, no problem. If x is a 6, we say 4/3 of 6 is 8. Right? Big bubbles, no trouble. Here, if you put in an 8, a lot of people go math crazy and they do weird, a 6. If you put in a 6, people go math crazy and they do weird stuff. They'll take the 6 times the 1/3 and then they'll add 1. That's what they usually do. But really it's 1 plus 1/3 times 6. So 6 plus 1/3 of 6 is 6 plus 2 is 8. So improper is really a word that causes a lot of confusion in some circles. And here is another example of that. For example, suppose I ask you to find under the curve y equal 1 over x squared. You might remember that 1 over x squared has asymptotes, horizontal on both sides, vertical asymptote at the origin, at the x-axis, y-axis, pardon me, and then the curve looks like this. Now, if I asked you to find the area under the curve between 1 and 2, no trouble, right? Very easy to do. If I asked you to find that area, what would you do? I'd integrate from 1 to 2, 1 over x squared dx. Right? Hopefully you can do that in your sleep now. What if I asked you to find the area from 1 to 5? What if I asked you to find all of the area, all the way?
Infinity?
Well, there, that's your first improper integral. The only thing is infinity's not a number. I guess what they're trying to say is find the limit as t goes to infinity of the integral from 1 to t of 1 over x squared dx. By the way, what is the integral of 1 over x squared dx? Minus 1 over x. And I guess we're going to evaluate that now from 1 to t. So I'm going to plug t in, I'm going to plug 1 in. Well, perhaps you'd rather get rid of the minus sign. I know I would. So I'm going to rewrite this as the limit as t goes to infinity positive 1 over x, which means I'm going to switch the limits of integration from t to 1. So this is the limit as t goes to infinity. If I plug in 1, I get 1. Minus, plug in t, I get 1 over t. Let t be infinity. So there's a strange result. If you had that region, which goes on forever, there's always area out there, no matter how far out you go.
And yet?
And somebody asked you to paint it. You could buy enough paint. And you'd never use it all up, right? 1 gallon of paint is all it's going to take. Of course, you'd never get it painted. You'd have enough, but you'd never do it because you'd have to keep going forever, painting smaller and smaller amounts. Is this a very odd sort of idea? So you can have an infinitely existing region and yet have a finite area? Get used to it, because that's the real world of mathematics. That's the entire thrust of chapter 11. That we're going to do the last chapter in this book, is to look at those concepts. By the way, we could also have the same thing for a vertical asymptote. What if somebody, I can't use that curve because that won't work against a vertical asymptote, but what if some little creep, what if they asked you to do the integral from 0 to 1 of 1 over rad x dx? I can't plug x equals 0 in there, can I? The graph of 1 over rad x, well, rad x only exists for positive x's. It looks like just the right half of that over there. Asymptote, asymptote, here's the graph. So what they're asking us to do now is find that area going on up forever and ever and ever. So I guess now they're asking me to find the limit as t goes to 0 from the right, integral t to 1, x to the minus 1/2 dx. Somebody brought their pet gnat to school and it's bugging me. Well, I guess it should bug me, it's a gnat. Although gnats aren't really bugs, right? They come from, isn't it Hymenoptera? Jenna? Lepidoptera is the butterflies and the moth? I forget.
And so there's a genus called bug?
Yeah, oh yeah, bug is a particular kind of insect. Not all insects are bugs, very few of them actually. Spiders aren't even insects, are they? Blessed I must stink, it loves me. So help me out here. How do you integrate this ugly mother? Limit as t, why am I going to 0 from the right only? What is the integral of x to the minus 1/2? Very good, 2 rad x. So, I guess I want to do the limit as t goes to 0. Go away! As t goes to 0 from the, I was talking to the gnat, not you guys. So that's 2 minus 2 rad t. And if I let t be 0, any of you guys ever had a statistics course?
Yes.
I like the way he said that. Well, then
Psychological
you know what the normal,
statistics.
You know what the normal curve is, don't you? You've seen the bell-shaped curve. When you beg a teacher to curve the test, you don't really know what you're asking. You don't really want a curve. A curve is not a pretty thing for tests. No, what you want is something called a weighted percentage, because then the teacher can basically force the grades into anything they want. That's what I do, so that I can give you whatever grade I want to give you. As long as I give other people that have a score the same as yours the same grade. So that's how I try to raise your scores at the end. I look until I see somebody on the list I don't like, and I say, well, let's go down to there for the A. You don't believe that, do you? I guess it could be true, but I don't do it that way. So what the hell was I talking about? Oh yeah, the normal curve. Normal curve kind of looks like this. It's a bell-shaped curve. It's got horizontal asymptotes here. And it looks like that. The area under that curve is 1. So since 1 is equal to 100%, in statistics we relate regions of that curve, area under that curve, to probability, right? The entire area under the curve is certainty, 100%. 1. That equation is not a real pretty one, but you can actually do it now. It's an exponential. It's like, what is it, like something like this, 1 minus x squared, I believe.
I've
As x
tried to
gets
forget.
bigger and bigger and bigger, whether positive or negative, that goes to 0. The maximum ends up being at x equals 0. It's something like that. So how, when somebody was inventing this statistics, how did they come up with the area equal 1? Well, here, now let's not do this one because it would be a trifle difficult. This would be much easier. And that has essentially the same shape. Notice it's always positive. As x gets bigger and bigger and bigger, whether positive or negative, y goes to 0. So it's something like that. Find the area under the curve. Well, I guess what I'm looking for is the integral from minus infinity to infinity of dx over 1 plus x squared. I guess, if you remember your Calc 1, I could break this at any constant, like minus infinity to 0, dx over 1 plus x squared, plus the integral from 0 to infinity. Each one of these, now I didn't have to use 0, I could have used any number, but 0 is a nice number to plug in as a limit of integration. That's why I chose 0. So if you want to plug in pi square roots of e here, go right ahead, knock yourself out. While you're at it, why don't you take something hard and hit yourself on the head a few times? Just enjoy yourself. So 0 is an easier number. So I'm going to have to write this as 2 integrals. I'm going to have to look at the limit as t goes to minus infinity, integral t to 0 dx over 1 plus x squared, and add to that the limit, now I can't use t, I've already used t, as k goes to positive infinity, integral 0 to k dx over 1 plus x squared. Well, another reason I chose 1 plus x squared is we do not need any magic to integrate that. What is the integral of 1 over 1 plus x squared? Arctan, very good. So this is the limit as t goes to minus infinity of the arctan of t, excuse me, this is the arctan of x, evaluated from t to 0. This is the limit as k goes to positive infinity, the arctan of x, but evaluated from 0 to k. So I guess we're going to plug in 0 and t, and then 0 and k. So we've got the limit as t goes to minus infinity. The arctan of 0 minus the arctan of t plus the limit as k goes to infinity of the arctan of k minus the arctan of 0. What is the arctan of 0? 0. So I've got 0 minus what happens to the inverse tangent as t goes to negative infinity? Minus pi over 2 plus as k goes to plus infinity, the arctangent becomes positive pi over 2. Again, the arctan is 0. Remember the graph of the arctan? I've stressed this. This problem and others similar to it are why I wanted you to know the graph of the arctangent. Right? So the arctangent gets close to minus pi over 2 as it goes to negative infinity. Positive pi over 2 it goes to plus infinity. So the area under that curve is pi. Improper integral. Yes?
Why we didn't write from negative to t, then take the limit?
From what?
From negative to t, then take the limit t goes to infinity.
Where did you want me to write that? Are we talking blue, green, or black here?
Blue.
Blue. So where did you want me to write it?
Change the infinity to t, then take the t, write it in one integral. Just one integral, rather than break it into two integrals.
Oh, I see. Because this is an even function, you could have done that. I understand what you're saying. I was trying to illustrate that when you do the integral from minus infinity to infinity, you have to break it into two separate integrals. So I was trying to get across a point. If I was really doing that problem, then yeah, I would have just doubled the integral from 0 to infinity. So, that was 7.8. Hope you enjoyed it. So would you like me to show you the kind of trick I'm going to pull on you on the test?
Yes.
So be warned, here's the kind of problem I'll give you. I'll say something like, let's do the integral from 0 to 1 of, say, dx, let's say 0 to 2, dx over x minus 1. Well, no, let's not do that one. Let's do 0, let's do an x minus 1 squared. So if you don't realize that in the middle of this interval from 0 to 2, there's a vertical asymptote, what you're going to do is say, I can't believe that jerk Larry actually gave us an easy problem. Because that's easy to integrate. That's minus 1 over x minus 1. Now, if you just blindly plug in 0 and 2, it's going to look great. But actually, you're going to find out that that area is infinite in extent. It does not exist as a finite number. Right? If you plug in 2, you get minus 1 over 1. Minus, plug in 0, you get minus 1 over minus 1. So you get minus 1, minus 1. Isn't that kind of strange, though, that you had something that was not negative, totally above the x-axis, and yet you came up with a negative area? Would that have clued you in that, uh-oh, something is amiss? And
You're giving us far too much credit.
Yeah. What you really have to do here is you have to say that's the integral from 0 to 1 of x minus 1 to the minus 2 dx plus the integral from 1 to 2, x minus 1 to the negative 2 dx. And when you do either one of these, you're going to come up with infinity as an answer. Okay? So you got to watch out for that. I mean, it's real obvious if I do a limit at infinity. You realize right away, oh, that's not a number. I need to use this improper integral stuff. But if it's across a hidden vertical asymptote, now you got to keep your wits about you. So didn't somebody say they wanted an assignment on 7.8? And isn't tomorrow our last opportunity to answer questions before Thursday's party? So you need to make sure that you get to the homework tonight. I'm sorry if it's getting in the way of your drug taking and your drinking, but you're the one that signed up for this. Now, I'm going to deliberately skip something called the comparison theorem, even though it's important. But the reason I'm going to skip it is because we're going to do it all again in chapter 11. Hoorah. So let's here do 1 through 39 the odd. So notice this is only like an extra, well, I guess it's still a lot, it's an extra 30 or 40 problem. But it's not as many as you had last night, so hopefully you'll have time to get to this stuff tonight. And I need to throw in a couple of extras, 57, 58, and 59. And now let's go back to finishing this stuff.